This is video number 1 for section 2.3, function notation with equations. We've been talking about functions for a little while now, and what happens as you go on in math is it becomes desirable to give your functions names. It just makes it easier to talk about the functions. The most common thing to do is just to use single letter names, something like F or G or H or some other letter. In this video, we're going to talk about how this new notation shows up with equations specifically. Well, so I've given an equation down here, and I think you would agree that this equation is an example of a linear function. I know it's linear because it fits the y equals mx plus b pattern. And then I know it's a function because we said all lines are functions other than vertical lines. And this is not a vertical line, so I know this is a function. How does this function work? In other words, how does this function determine its outputs? Well, let me see if I can draw you a picture to help illustrate that. Remember, a function is kind of like a machine with an input slot and an output slot. So I've named this particular function machine f. How does it work? Well, x represents the input, the number that's being stuck in. What does this equation do to its input? Well, it takes it, it multiplies it by -1/2, and it adds 6, and whatever the answer is to that bit of math is what then comes out. Looking back at the original equation, you could even read this, the output is always -1/2 times the input plus 6. Well, we would like to have a way for the name of the function to show up right in the equation, and so here's how that works. We basically are going to be today taking the letter y and replacing it with this notation, f of x. That's how you read that, f of x. Right off the bat, I got to clear up something. Often in math, when we put two letters next to each other with parentheses, it means there's some kind of multiplication going on. That is not the case here. This has absolutely nothing to do with multiplication. F isn't even a variable. It's just the name of the function. F is the name. The of x part is simply a reminder of the fact that the input of this function is x. Well, now that I have that new notation, I have this alternate way of writing down my equation. Instead of writing y equals -1/2 x plus 6, I can write f of x equals -1/2 x plus 6. The two equations are identical. It's the same thing, it's the same function, they work the same way. This is simply a new way to write it. Now, right here in the equation, I have the name of the function. I have an input slot. You might think of it as a holding place for my input. And just as we've had before, I have on the right side a formula for computing the output. So I have the name, an input slot, and a mechanism for calculating the output. Now, a good question at this point is, why do we need this? I mean, wasn't x and y good enough? Couldn't we have just stuck with this? And there will certainly be times where we just stick with x and y. Let me see if I can show you some of the nice features of using this new notation. Let's take a look at this first example. Once I have the new f of x notation, I can say things like this. I can say, find f of -2. That's how you would read that, f of -2. What is that trying to say? Well, what that means is go to function f, please stick in -2. Remember, the parentheses next to the f is an input slot. It's a reminder of what the input is. Go to function f, stick in -2, and tell what comes out. Well, how am I going to do that? How am I going to find f of -2? Well, that's where the equation comes in. this formula says, here's what function f does to your inputs. It takes it, it multiplies it by -1/2, and it adds 6. So that's what I'm going to do. I'm going to recopy the formula on the right. When I get to the x, I'm going to remember, hey, that's really just a slot. That's an input slot. And then I'm going to fill my desired input, my -2, into that slot. What a lot of people say is whatever replaces the x in this parentheses replaces the x on the right side. I have a little calculation to do now, and whatever I get, that will be my answer. Let's see, it looks like I need to multiply here. If I put a 1 under that, I think that looks more normal. The 2's are going to cancel out. The minus signs are going to cancel out. I think everything's gone there. All you have is a bunch of 1's everywhere, right? So that's just 1 plus 6, which of course is 7. And so our final answer to this little problem, f of -2 equals 7. Again, all that means is when you stick -2 in, you get 7 out. Let's try another one. This should be similar, I think. It says find f of 15. Again, that's how you say that, f of 15. Well, it's the same thing. Go to function f, stick 15 in, and see what comes out. Well, I'm going to recopy that output formula again. When I get to the x, I'll put my empty slot, and then I'm going to stick the 15 into the slot. And it's the same thing. I just need to work out the math, and I'll have my answer. Now, this one looks like the math is going to be a little bit messier. I'll put the 1 under it. I don't have any canceling that happens to me this time, so I'll just multiply straight across. -1 times 15 is -15. 2 times 1 is 2. And let's see, I have a little bit of a mess this time. I'm going to have to find a common denominator so that I can add these pieces together. I'll think of 6 as 6 over 1. Looks like my common denominator would be a 2. So I'll have to multiply the top and bottom of this guy by 2 so that I can get that common denominator. And that gives me -15 halves plus 12 halves. Now that I have the common denominator, I can add the tops. -15 plus 12 is -3. The bottom stays the same. This doesn't reduce. And so here is my final answer. We were asked to find f of 15, and our answer is -3 halves. Again, that just means when 15 goes in, -3 halves comes out. All right, let's look at another one. Now this next one is worded a little bit differently. It says find x if f of x equals 20. Take a look at that, compare it to the one that came before. Hopefully you can see the difference. That 20 there, that's not an input. If it was an input, it would be in the slot. It would be in here. All right? I don't know the input. That's why they're telling me find x. X is input. I don't know that. What's the 20? Well, the 20 is the output. I know that because remember, f of x, completely interchangeable with the letter y. When you see f of x, you could erase it and write y. It's the same thing. You might as well read this, find x if y equals 20. In other words, if the output is 20. Let me recopy our function. So here's our function. Remember, this time the x is not given. The f of x is given. So I'm going to go to this equation, and where I see f of x, I'm going to replace it with the number 20. That's like filling in a y value of 20. And now what am I going to do? Well, I'm going to have to solve this equation then for x. I'm going to have to do some algebra. Let's see. You've got a couple of choices of what you could do here. Maybe I could start by moving that 6 to the other side. And then it looks like clearing the fractions might be a good idea. LCD is 2, so multiply both sides by 2. On the right, those 2's are just going to cancel out. Now I have 28 equals -x. Divide both sides by -1, and I think I'm done. Looks like my final answer to the problem, x equals -28. This answer is a different kind of answer than the other problems, right? We were not asked to find the function value. We were asked to find an x, and so we did. X equals negative 28. Well, let's take a look at the next example. This one says, find f of 4b. Find f of 4b. You say, what in the world is that? What's b? I don't know what b is. It's just some unknown number. I don't care what b is. I'm never going to know what it is. What in the world am I being asked to do here? Well, remember, a function is like a machine with an in slot and an out slot. What's the 4b? Well, it's in there in the parentheses. That means it's an input. I am being asked, go to our good old function f, this guy that we've been working with, and dump 4b into the in slot and tell what comes out. Well, I'm going to do this the same way we did a couple of the earlier examples. If I want to find f of 4b, I simply copy down my formula for finding outputs. When I get to the x's, I open up a slot. And this time I'm dumping something kind of strange into the slot, but I'm going to go ahead and put in this 4b. All I need to do is work out the math here, and I'm done. Let's see, again, a fraction times a whole number. It would be helpful to put a 1 under this. I do have some canceling. There is a times right here. 2 goes into 4 twice, so I can divide those by 2. And let's see, that gets rid of the fraction, actually. So negative 1 times 2b would be negative 2b. And then I have the plus 6. That's it. That's as much as I can do. If nobody ever is going to tell me what b is, then I don't have any way to further work this out. And so what we're saying is when you stick 4b into this function, you get negative 2b plus 6 out. That's the answer. Well, let's work one last example. I just want to show you some things to watch out for. Notice in this last example, I have changed functions on us. So we've been working with that one f of x function this whole time. This is now a brand new situation. This is function g, okay? And g of x is a lot more complicated. This is kind of a messy function. We'll do equations like this later on in the course. This is certainly not linear, but the same principles apply. I have a function and I'm being asked to stick something into it and see what comes out. Well, it's the same approach we were using before. If negative 2 is my input, if that's what's replacing the x on the left, that is the number that needs to replace all of the input slots on the right. Notice there's more than one. And again, I think actually creating for yourself the slots is a very good idea, especially when there's negatives and exponents. You'll save yourself a lot of mistakes if you do that. Okay, I've got my slots all set, and then in the slots I'm going to fill in my negative 2. And then I just have some math to work out, and I'll have my answer. That parentheses on the top is really important because the negative is inside the parentheses. That means it's negative 2 times negative 2, which is positive 4. On the bottom, I have negative 2 plus 5, which is 3. Wrapping up the numerator, I get a 5 up top, a 3 on the bottom. That doesn't reduce or simplify in any way, and so I'm finished. I say g of negative 2 is 5/3. All that means, when I stick negative 2 in, I get 5/3 out. Or another way you could say it, when the x is negative 2, the y is 5/3. We will be using function notation quite a bit as we move through this course.